For day 2 of this lesson, we're solving rational inequalities. The steps are shown at the top. First thing you're going to do is state the excluded values. An excluded value is any value that makes the denominator equals 0. So on number 1, what would make that 0 if p was 0? What would make this one 0 also if p is 0? That can never be 0. So the only excluded value is p does not equal 0. Okay, next we have to solve the related equation. Notice it says equation and not inequality. So you're going to pretend it's an equation and solve it. So I'm going to rewrite it as an equation. Okay, the LCD of that equation would be 15p. 15p is the smallest expression that all three denominators would go into. 3 and 5 both go into 15, and then the biggest exponent on p is 1, so 15p to the first power. Okay, this is what we did in the last lesson. First fraction, the p's cancel out, and we're left with 5 times 15. Second fraction, 15p divided by 5p is 3. 3 times 6, well, I'll write that out, 6 times 3. 15p divided by 3. I like to divide first so I don't have big numbers. 15p divided by 3 is 5p times 2. So 5p times 2. I'm going to simplify. 75 plus 18 equals 10p. 10p equals 93. So p equals 93 over 10, or 9.3. So usually after you solve for the variable, you're done, but these are equations, not inequalities, so we still have step 3 to do. Step 3, use the values from step 1 and step 2 to divide a number line into regions. Test a value in each region. Alright, so I'm going to make a number line. And step 1 gave us 0. Step 2 gave us 9.3. So we're going to divide the number line into 3 sections. 2 cuts makes 3 sections. And now we need to test numbers in each area. Alright, so going back to the original inequality. So first I need to test a number smaller than 0. I think I'm going to try p equals -1. So if I plug in -1, I get -5, and then 6 divided by -5 is -6 over 5. Is that greater than 2/3? Well, a negative number can't be greater than a positive number, so this area does not work. Alright, now we have to test a number between 0 and 9.3. I think the easiest number to test there would be 1. So I'm going to plug in p equals 1, and we get 5 plus 6 over 5 is greater than 2/3. Well, 5 alone is greater than 2/3. So if we add another positive number, it will still be greater than 2/3. So this middle area works. Now we have to test a number bigger than 9.3. So I think 10 might be a good number to test. I'm going to plug in p equals 10, and I get 5 divided by 10 is 1/2 plus 6 divided by 50 is greater than 2/3. I'm not sure, so let's simplify a little further. So 1/2 is 0.5 plus 6 over 50 is 12 over 100, so 0.12. Is that greater than 2/3? 0.62 is not greater than 2/3. 2/3 is 0.666 repeating, so 0.62 is not bigger than that. So the only area that works is this middle area. So now we could write our final answer, 0. Okay, I also need to put circles. At 0, we need an open circle because it's not allowed to equal 0. At 9.3, we need an open circle because the original says greater than. It doesn't say greater than or equal to. All right, so 0 is less than, P is less than 9.3. Okay, for number 2, we're going to do the same steps. So the excluded value is x does not equal 0. Now, will it always be 0? No. If the denominator said x plus 2, then the excluded value would be -2. Okay, so now we pretend this is an equation, and we solve. So pretending this is an equation, I need to multiply by the LCD. 3 and 9 both go into 9. And x to the first is the biggest exponent we see. So we're going to multiply everything by 9x. First fraction, 9x divided by 3x is 3. 3 times 4 makes 12. Second fraction, 9x divided by x is 9. 9 times 7 makes 63. And I'm pretending this is an equation. 9x divided by 9 is x. X times 5 is 5x. So we end up with 5x equals 75. So x equals 15. Now we make our number line. So step 1 gave us 0. Step 2 gave us 15. All right, so I'm going to tell you guys a shortcut. You don't have to test every single region. You can test one region, and then it'll just take turns after that. First, let me put the circles, though. We know we're not allowed to equal 0. So open circle on 0. We're also not allowed to equal 15 because the original problem said less than. It didn't say less than or equal to. So now we have 3 regions, and we just need to test one of the 3, and then I'll show you what to do after that. So what would be the easiest number to plug in? I'm thinking x equals 1. Seems like a pretty easy number to test. So if I do that, I get 4 over 3 plus 7. Is that less than 5 over 9? Well, 7 alone is already way bigger than 5 over 9. So if you're adding a positive number to 7, it's going to be significantly bigger than 5 over 9. So this does not work. So when we plugged in 1, which falls in that middle region, it didn't work. And it will always alternate. So if the middle doesn't work, the ones next to it has to work. So it always alternates from working to not working. Okay, so we know that x can be less than 0 or x could be greater than 15. On number 3, we're going to go back to solving rational equations with a word problem. And this word problem is about work. So Noah and Owen paint houses together. Noah by himself can paint the house in 6 days. Owen can do it in 5 days. So obviously if they work together, it will take less time because they're helping each other. So I can already tell just by looking at it, the answer is going to be somewhere between 2.5 days and 3 days. Because if you look at it this way, if Noah painted half the house all by himself, that would take him 3 days. If Owen painted half of the house by himself, it would take him 2.5 days. So after 2.5 days, Owen would finish his half, and then he would start helping Noah with his half. So if Noah didn't get any help with his half, it would take 3 days. So somewhere between 2.5 and 3 days. Okay, so how long would it take them? I'm going to call this time X. So we know that Noah can paint in 6 days. So what could Noah do in 1 day? He could do 1/6 of the job. What could Noah do in 2 days? He can do 2/6 of the job. In 3 days, he can do 3/6 of the job. So what could he do in X days? Well, in X days, he can do X over 6, that fraction of the job. Okay, Owen can paint the house in 5 days, so obviously in 1 day, he can do 1/5 of it. In 2 days, he can do 2/5 of it. In X days, he can do X/5 of it. Together, we are finding the amount of time it will take them to do 100% of the job, or 1/1. Okay, what's the LCD? And I'm going to make this over 1. 6, 5, and 1 all go into 30. So 30 divided by 6 is 5, times x makes 5x. 30 divided by 5 is 6, times x makes 6x. 30 times 1 is 30. So we get 11x equals 30. X equals 30 over 11, which means x equals 2 and 8 left over. 2 and 8 over 11 days. But nobody really talks like that, so I think it makes more sense if we say 2.7 days. We have another work problem on number 4. It took Anthony and Travis 6 hours to rake the leaves together last year. The previous year it took Travis 10 hours to do it by himself. How long will it take Anthony if he rakes them by himself this year? So Anthony's amount of time, that will be our variable. So what can Anthony do in an hour? If Anthony normally takes x hours, then in 1 hour he can do 1 over x, that fraction of the job. Travis can do the job in 10 hours, so in 1 hour he can do 1/10 of the job. And we know that working together in an hour, they can do 1/6 of the job. So I've set up my equation based on what everyone can do in an hour. In an hour, Anthony can do 1 over x of the job. In an hour, Travis can do 1/10 of the job. And working together, they can do 1 over 6 fraction of the job. Okay, so the LCD here, the smallest number that 6 and 10 both go into is 30. And we also need an x. 30x divided by x is 30 times 1, still 30. 30x divided by 10 is 3x. 30x divided by 6 is 5x. So we get 2x equals 30. So x equals 15. So by himself, Anthony will take 15 hours. Okay, the challenge problem doesn't look too challenging. We start with our excluded values. X does not equal -2. X also does not equal 1. Then we solve the related equation. So even though it's an inequality, we pretend it's an equation, and we solve that. So our LCD is going to be 2. Then we also need an x plus 2 and an x minus 1. In the first fraction, x plus 2 cancels out. So we're left with x times 2 times x minus 1. In the second fraction, x minus 1 cancels out. So we're left with the 1. I don't need to write the 1. 2 and x plus 2. And we're pretending this is an equation. In the third fraction, the 2 cancels out, and we're left with 3 times x plus 2 times x minus 1. Okay, for the first set of parentheses, I'm going to distribute a 2x, so we get 2x squared minus 2x. Now I'm going to distribute the plus 2 plus 2x plus 4, and it equals, I'm going to FOIL first, x squared minus x plus 2x. Those combined make plus x, and then minus 2. 2x squared, the negative 2x and the plus 2x cancel out. This equals 3x squared plus 3x minus 6. I'm going to move everything to the right. So I'm going to have 1x squared plus 3x minus 10 equals 0. That is factorable. Looks like x plus 5, x minus 2. So x could equal -5, or x could equal positive 2. So then we make our number line. And we have, it looks like we have 4 numbers that we need to put. So the smallest of these 4 numbers is -5, followed by -2, and then positive 1 and positive 2. Okay, so remember, I taught you guys the shortcut. You don't have to test every region. My shortcut will work as long as none of these are squared. So that's not x plus 5 squared, so we're okay there. That is not x minus 2 squared, so my shortcut will work. The shortcut is that you test one region. So what jumps out at me is that x equals 0. Looks like something easy to plug in, and keep in mind you're not allowed to plug in any of the numbers on your number line. So don't plug in -5, -2, 1, or positive 2. So x equals 0 will work because 0 is not one of the numbers on our number line. So if I plug in 0, I get 0 over 2 plus 1 over -1 is less than 3 over 2. Okay, so that becomes -1 is less than 3 over 2, which is true. So we know that the area that has 0 works. And by the alternating method, that means this area does not work, and this area does. This area here does not work. This area does. So we have 3 areas that work, and we need to write all those out. So our final answer is x is less than -5, comma, -2 is less than x is less than 1. And we could put open circles here because the excluded values always have open circles. And the original problem did not say or equal to. It only said less than. So we put open circles for everything. And then our last region is or x is greater than 2.